we will be looking at assembly language capitalization of a string. We're going to see if we can make it work. Well, I mean, we already know it works. It's a tutorial. We're just walking through the tutorial. We're reading the details on the tutorial, and we're going to see how it works. And this is learning. We're learning together. We're learning together. Here today, we'll be learning together. So let's go back into this. Okay, so here's the string that we're going to capitalize right here. Right here, you see it on the screen. This is our test string that we will convert, right? This will be converted into capital letters. And it should work already. I believe it should work. We just need to understand why it's working. So there's a few new items that I'm seeing here on the screen that I'm not familiar with, like ADRP. I don't know what this is. Let's see if we can figure it out. Let's see if we can figure out what ADRP is. We'll see if we can make that something that we know. All right, let's take a look here. ADRP, ASM, assembly instruction. All right, what does this do? All right, looking it up. We're reading the details here. All right, ADRP, address of page. Address of page, okay. And then in string, I believe, is, okay, so ADRP in string is going to be this variable, which is an ASCII Z. I don't know why there's a Z on here. Why is there an ASCII Z on this? I understand ASCII, but why is it ASCII Z? Let's see. All right, so let's before we jump in. So ADRP here. ADRP is, let's look over here. The register and then the label. Okay, so we've got register 0, which is the very first one, and then in str is the label, right, for the string right here. So we see here on the string, we see the string there. Let's see, blah, 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 64-bit destination, register, right, register, program label whose 4 kilobyte page address is to be calculated. Interesting. Okay. So why is there an at page on it? That's what I want to know. Because it looks like you could do ADRP without at page. It looks like you can do it without at page. Let's see here. Let's bring this up. Okay, make, clean, make, and then LLDB. Oh wait, actually, do you know what file is this here? This is main. What's going to be the output? It looks like it's going to be upper. See, ./upper. Okay, so here is the output. As you can see, it's fully converted. You look over here, we see here, fully converted. Looking good there. The test string looks good. So you can see it works. It works as expected. So what if we also say hello? And that we have an exclamation point in there. So I don't know what that's going to do. Well, let's find out what that's going to do. And then we will rebuild this. And then ./upper, I believe. Okay, so it did. It worked. Okay, so as you can see here, hello, this is our test string that we'll convert. And it did. It converted. So let's mess with it now. Let's mess with it. Let's see if we can understand more details. Now, what is this? What is the out string? So this is the output. So if we printed in string, it would be the original. Out string is going to be the new. Based on, it looks like 4 kilobytes. Obviously, this string right here that you see here, that's definitely not 4 kilobytes. That is not 4 kilobytes. So good news is there's plenty of room. There's plenty of room in that page. Mm-hmm. Let's see here. And then what is this part? What are we doing here with the page off? Add. So this is going to be, hey, Reba, hello, question mark. Hey, how's it going? Welcome on in. Good to see you. Reba call. Katal. Wait, yeah. Katate? Wait, what? I didn't say your name. It's good to have you here. Happy to have you here. We're looking through assembly code right now. We're learning how to convert a string into uppercase. As you can see here, it's already there. It's already there. Yo, Deepak, how's it going? Yo, happy to see you here. All right, let's see here. The add. Okay, so this second line we're looking at right now, you can see right here on the screen, we're looking at that line right there. This is going to, I believe, increment. It's going to update. Here's what I want to do. I want to run a BRK number 0. Just a number 0, BRK number 0. I think that should be fine. And then I want to understand what this looks like before and after. So let's do this. Let's do BRK right here. Let's see what X0 looks like. Okay, let's run this, and then we'll say LLDB upper. Okay, run. Let's see here. 1 second. All right. Enter. Hey, how's it going? Hulk Logan. Hey, Logan. Hey, how's it going, Hulk Logan? Good to see you. Welcome on in here. I'm Amelia. Oh, Amelia. All right. Welcome on in. Happy to have you here. We're looking at some assembly language today. We're looking through assembly language. And so we're going to see what this is here. This looks like, see. So we've got a break statement that occurred. The X0 register. I want to see. Okay. Sounds good. All right. So I want to see. So wait, where is that? So here's our BRK, and then X0, frame 0 says a number. So let's print money X0. What does that look like? Okay. So that is the non-hex value. What is read register X0? Okay. So that matches up. That matches up. So you can see here, it matches up. So right here matches up with this. So what are you doing? Hulk Logan. So the goal is to understand how to capitalize a string in assembly language. So we're using assembly code that compiles, we don't have a compiler. We have an assembler and we have a linker. So we don't, when you're writing straight in assembly, you do not need a compiler. You just need the assembler and linker. And the assembler changes the machine code, and the linker brings it. Oh, hey, Mr. Nanaban. Mr. Nanaban. Thank you for subscribing. Happy to have you here. I like your name. That was funny. Hey, Kyle, you made it. Welcome on in. We're continuing from yesterday. We're continuing from yesterday's stream where we are going to convert a string into capital letters, capitalize it. So we're going to walk through each of these steps. We're going to walk through each of them. So we've got, we're seeing the X register 1 or X register 0 there. It looks good to me. So that looks like an address, just some sort of address here. Starting of input string. That's where the input string is addressed at. Hulk Logan, you subscribed. Thank you. Thank you for your subscription. We're working on some assembly today. We do a lot of things. So we do a lot of software engineering on this channel. We focus on AI. We're gonna be focusing more on AI. Right now we're doing assembly because it's fun. It's neat. We're learning a lot. It makes it easier to understand how programming works in general from a higher level. Yeah, welcome. Nice. Thank you again. Thank you. All right, so let's keep going here. So this looks like the start. So this is going to do some interesting. So I don't understand. This is going to update. This is going to add. So this is adding the existing address, and it's going to take the page off. So I believe it's going to turn it into, yeah, you get it? Nice. Excellent. Good to hear. Okay, so I want to see what happens with this. We'll see what this does. What is it going to do the first register? All right, so yes, okay, looks good. All right, make clean LODB. Run. Okay. Okay, so okay. It looks different. It looks different than what I thought it was. I did not think it was going to look like that. So interesting. So that is a different number. Let's zoom up here. So that is the exact, no, it's exact same number. Wait, what did that even do? What does this do? I don't know how you do this though. Oh no, I hope you're feeling okay. Don't worry about that. About how to do it though. Well, I don't either. So we're figuring it out together. We're walking through this together. This is assembly language. It's okay. Nice. Okay. Okay, so let's see here. This is not what I was expecting. Did it compile? It must have compiled. So let's see here. Let's rerun, make, rebuild. Wait, hold on a second. Make clean L. All right, so it did get rid of it. Okay, good. Run. It stopped. Wait, what? Why did it stop? Run? Yes. Okay, there we go. register 0. It's just so weird. You have school tomorrow? Oh, hey, Prince Clint. How's it going, Prince Clint? Welcome on in. We're doing some assembly here. It's a half day. Nice. That's great to hear. Half day is great. That's the best. Well, no day, right? So a day off completely. That's the best kind of day, right? The best kind of day ever. Half day, a good second place. It's a good alternative. All right. So this was not revealing. I don't understand what's going on there. So let's take this. I want to see what X. Let's look at X register 1 now. Let's do this. All right. So let's exit, make clean, run, and then yeah, half day. There we go. Half day. All right. So take me RERX2. What does that look like? Okay. And then RER. Well, let's do it together. X1 and X2. Here we go. Perfect. Oh, interesting. The label outstring X1. Oh, right. X2. We didn't do anything. X2 is just whatever it was before we started the program. All right. So the register is just left over. So we want X0 and X1. Here we go. There we go. Look at that. And what's neat is, this is really neat. I didn't know that it would do this. It keeps information about what label it's assigned to. That's very satisfying. I like that. I very much like that. Okay, so X1, and this, from my understanding, if we're looking at this here, X1 is just going to be the start of the input for X1. Is it though? Or is it? I don't know exactly. We'll keep going. We'll see what this is. All right. So BL, remember from yesterday, BL is a branch with link, which is basically calling a function, which is toUpper. toUpper, I believe, is defined in another file here, probably here. Here it is, toUpper. So excellent. Okay. So this is going to be the input and output. We understand that. So X register 0 and X register 1. These are going to be essentially the parameters that we're going to be used passing into the concept, conceptually. You'll be back? All right, cool. Hulk Logan, sounds good. We're walking through this here. Okay. So let's take a look over here. So toUpper, we're going to move X4 to X. X4 is going to equal X1. So essentially, we're saying X4 is equal to X1 at this point. Which should be, if we throw our break statement over here, this should give us, this X1 and X4 should be equivalent. They should be equal. Let's see here. We'll do that. Okay. Let's rerun this. Run. Okay. Hey, which language is that? This is assembly language. And there's different languages for different target operating system architecture, right? Different architectures, which are different CPU structures. RISC, ARM. Well, RISC is a series, right? You've got x86. You've got ARM, which runs on your phone, right? And MacBooks and MacBooks these days. You're back, Hulk Logan. Nice. Good to have you back. You weren't gone for very long. So this is assembly language, and this one specifically is ARM64 instruction set. So we're doing a new break statement there. Okay. What I'm wondering, I want to try this. What if we do break 1 and then we do break 2? Let's do that. This will be break 0. Did you see me? Or do you see me? I only see, wait, hold on a second. One moment. Let me go over here. One moment. Clicking buttons. Okay. There we go. I see that you're here. I don't see anything else. Let me see. I'm pulling that up here. Excellent. Okay, great. Okay. I want to add in X. So here we go. BRK number 1. Let us rebuild this with the new break statement. And I want to try to step. Okay, so we broke here, BRK. There is, wait, hold on a second. Wait. Is it REX1 and X4? Are they equal? No, RER, sorry. Okay, so it's X4 looks like it's nothing right now. So can we say step? and then run it again. Oh no, I pressed step. I should not say step. Okay. All right, so that didn't change. That didn't change anything. Hold on. Step. Wait. Help? Is there a help here? Okay. Let's look into this. Launch the executable in debugger. Source level. Script. Shell. Oh, look at all these fun commands. This is great. Launch executable. We are in run. Okay, they're the same thing. Q for quit. Print variable. REPL. Evaluate an expression on the current thread. Display any returned values. Neat. I didn't know you could do that. Source level single step. Stepping into calls. Defaults to the current thread unless specified. So S. So we could just do S. What about step? Source level. S versus step. What's the difference? So I'm looking at this here versus this here. What are these two? Wait, not script, but this. All right. S is source level single step. Stepping into calls. Source level single step stepping calls. Defaults to the current thread. Defaults current thread. They're the same thing. Okay. They're exactly the same thing. It would be nice if they just put them together instead of made it seem like they're separate. Okay. So what is steppy? Instruction level single step. Step into calls. Defaults to the current thread. Instruction level. So what is step E? Okay. Select an older stack frame. View variables from the current stack frame defaults. Var, show variables for the current stack frame. Interesting. Defaults to all arguments, local and variables in scope, names of arguments. I want to try var. What does that do? Nothing. Okay, perfect. Var inster. No variable. Okay. Var x0? No, that's, wait. Var x0. Not a variable name. Okay. Interesting. VO. Show variables for the current stack frame. So interesting. Let's try to run again. Okay. What we want to VO. Nothing. Var. Nothing. All right. Read from the memory of the current target process. X0. Okay. We're learning together. We're trying out all the different things. What is SIF? What is that? SIF, step through the current block, stopping if you step directly into a function whose name matches the target function. That is kind of neat. Okay, that is kind of neat. Instruction level single step. Oh, SI. Interesting. SI. Stopped. Okay. Run. Yes. There is running process kill and restart. Yes. SI. Interesting. Okay. What if we got rid of this? We went, whoop. Nope, nope, nope. Yes, yes, yes. All right. Rebuild. Run. Allow. Okay. Things are different now. Things are different. All right. Let's keep looking here. Okay. RER X1 and X4. Hey. Okay. We're figuring things out now. We're figuring things out. All right. So when this is what I thought was supposed to see, I figured these are supposed to be equal. So wait 1 second. What about RO? No, a VO. Actually VO. Hey, Kyle. It's assembly. It is. Yep, you got it. We're doing some assembly here. We are doing some assembly. What about var? No, nothing var. All right. Well, I guess we haven't run into this yet before. All right. Okay, keep going. What is load register B? Let's look this up here really quick. Loop. Let's close this. All right, we're now inside this function, so we're just gonna focus on this function now. Load character and increment pointer. Okay, so register 5 is going to be x1 by 1 character. So this will give us the current character of the string, which is here, which would be in main. You can see here, which will be a capital T. Okay, so that'll be a capital T. So W5 should be the ASCII value of capital T at that moment. So if we throw the break statement here, and then we rebuild and run. Hey, thank you for the like. Appreciate the little heart floaty icon there. Okay. We should see REW5. Wait, sorry. RER. I always forget that. RER. Okay, so it's 54. Print money W4 or 5. 84. Is capital T the ASCII value of 84? That's what this is what I'm thinking it is. I think it is. Let's look this up. We'll go to the internet, ASCII table. Here we go. Let's grab an ASCII table here. It should be 84. Should be 84. All right, let's zoom in. All right, zoom in here. Zooming in. All right. Do I see a capital T? That is not easy to read. I need something higher resolution. Here we go. This is good enough. All right, capital T. It says 84. Hey, there we go. We're figuring this out. All right, so now we've got an ASCII value of 84, which is, this is the decimal value, 84. The hex value is 54. Okay. So, excellent. We're making our way. We're figuring this out. We're figuring it out. Okay, keep on going here. Let's keep on going. So now we've stepped into it. I haven't explored ASCII that much, and I really want to. It looks cool. It's actually pretty straightforward. So if we look at ASCII here, if we're going to look at ASCII, it is simply the assignment of your keyboard characters, right? The assignment of your keyboard characters to numeric values, which the computer understands. The computer understands ones and zeros or numbers. It doesn't understand anything else. All it thinks of is numbers, right? So as humans, we've assigned a table in order to print human readable glyphs, right? These like hieroglyphs, right? The glyphs, the symbols that we assign to. And you can see here, this is the table for the common symbols, like the most common symbols. Parentheses, math operations, numbers, the actual numbers themselves, the number glyphs, some symbols, the alphabet, and uppercase and lowercase. So that's it. That's all ASCII is. It's just an assignment of numbers to glyphs. That's it. That's all it is. All right. So going back over here. All right. Let us do, so when we say, ASCII art. Oh, ASCII art. Okay. Well, that's a whole different game now. You're doing something completely different. ASCII art is just a fun way to convert images or just draw in general using text to create pretty, right, let's look that up really quick. All right, Kyle, since you brought it up. All right, ASCII art. Let's look at ASCII art. So let's do ASCII art. Here we go. Images. See, all right, so we got some ASCII art here. So if we zoom in, let's see if we can zoom in. You can see it's a bunch of Z's and we get some I's in here. We've got some colons, some periods. Isn't that kind of neat? I think that's pretty neat. That's ASCII art for you there. That's some actual ASCII art. That's some nifty ASCII art you got there. Okay, let's go back over here. So I know this is we're going to compare W5 to the number, or I guess the letter Z in this case. The letter Z is going to, is there an ASCII art trained AI model? Oh, that sounds neat. You're on to something. Kyle, you're on to something. We should make that. Right? We should make that. I think that sounds like a good idea. How would we do that? So we would need the output would be some symbol. I would need to think that through. We need to think at how to design something like that. Apparently AI sucks at ASCII. In Discord, link in Discord. We can fix that. All right. Here's your link in Discord. Why? Oh, large language models. Okay. So here's one. Okay, Kyle. So in general, I've been noticing this problem on the internet. When everyone refers to AI, they are not talking about the algorithms. And the ability to make them train them the actual intelligence, machine learning. They're not talking about that stuff. They're talking about large language models. They're talking about ChatGPT. That's what they're talking about. When they say AI, they're talking about ChatGPT or like image generators, these large image generators. It's the whole world. That's just like the surface of AI. That's just the surface. Oh, okay, right? Yes. So AI can absolutely be good at ASCII art. It can absolutely be good at ASCII art. In fact, we can make one. We can make one that's very good at ASCII art. We can do a very good job at it, and it will do amazing. LLMs are a totally different situation. And it's not an LLM's fault. It's just that they're not trained on generating ASCII art. In fact, we might choose to use a transformer. You're so down? Nice. That's good to hear. I mean, that's good to hear because that's something that, I'm not sure if we'll ever be able to fix. I think that's just going to be, as the internet at large is going to have this just idea of that's what AI is. They're not going to see like the underlying parts, and then it can be made to be good at everything. So an LLM and LLMs and transformers, they're not at fault. ChatGPT, it's just not trained so much on ASCII art because, oh, hey, perfect. All right, you want to, it wants me. Okay. This is pretty neat. So I think we could potentially, if we got an ASCII art generator and then we got an image and then we trained an AI model to capture the generated. So that's what we could do. We could do sort of essentially reinforcement learning, take an AI, put it into a world where it sees the pixels of an image, and then the output would be a character and it like a symbol, right? Some sort of number on the ASCII table. We could absolutely do that. That would be great. I noticed that AIs are rude now. Are they? No, they went from one extreme to the other. LLMs used to overly nice. I was fine with the overly nice. They're like, oh, you're right. You're so wonderful. You did all the things that you should ever do as a human. Keep talking to me. All right, you're doing it right. Do not give up. I'm like, LLMs used to be overly nice, and now they're training on the other direction. I guess that's kind of funny. Me too. I know, right? Isn't it funny? So, you know what? I think I've got an idea. That would actually be a really fun. Let me write that into our Discord channel here. All right. So, future stream idea. Train AI to do ASCII art. We could do that. There we go. I like that one. That's good. It'll be balancing act. Gemini told me I was ranting today. It did? It's like calling you out now. Crush my morale, not gonna lie. Hey, Hulk Logan, good to see you. Welcome back. We're just looking at some ASCII art. We've got a future stream idea right here. We're going to train an AI to do ASCII art. I think it's fun. It's lightweight. And we could probably use a transformer to do it. I think we can do it. Sorry, you were gone a long time. No worries. We're just here. We're making our progress. So we've got a meeting coming up here in 12 minutes, which means I do got to get going in 12 minutes. However, let's keep going. So I didn't know that you could do this. This is neat. So Z apparently is going to be the ASCII value. You were eating? Hey, that's like the best thing. That's one of the best things in the world. I love eating. Eating is fantastic. Okay, this is neat. Okay, so if W5 is greater than, is W5 is greater than Z, that means what is this here? I think if it's greater than the lowercase z, we just skip. Is the letter larger than z? Wait, hold on. Yeah. No, wait. Let's look at the ASCII table again. Hold on 1 second. ASCII table, here we go. Okay. So lowercase is higher than capital letters, which is very strange. A good sandwich? Nice. And now it's time. Yep, doing the morning things or the wake up things. Food and bathroom activities. Shower sounds good. Okay, so Z is, where's Z at? Where I see W. I'm gonna assume it's just not visible on this table because they've truncated it to make it look pretty. So Z is up here, W X Y Z. So W X Y Z. So 122, right? So if it's greater than this, which it shouldn't be, this is very odd. So it should never happen. I feel like what we need to be doing is checking if it's, how would we go back? Oh, when do you drop your own language? Oh, hey, how's it going, Rusty Window? Rusty Window, how's it going? We could if we wanted to, right? Because we're working on assembly now, so we could build our own compiler. Hulk Logan, don't do. Feel good. Everything's okay. Everything's good. Let's see here. So, hi, I just joined. Attic. How's it going, Attic? I don't see if we pronounce your name there. Attic. We'll call you Attic. We're looking at some assembly code here at the comparison. So if it's greater than, right, continue, right, so compare greater than, right? That's what we're doing. We're comparing, we're seeing if it's greater than. What is C and T here? Oh, okay, it's just a label. It's just a label. That's all that is. Okay. So essentially what we're doing is we're seeing if we need to run the capitalization algorithm. That's what we're doing here. So if it is, let's see, letter is greater than Z, or if it's less than A. So this part right here I get, because if it's less than A, that means it's likely down here, right? It's down in the lower zone. So if it's down in the lower zone, then let's see. Yeah, thank you, Kyle. Thank you, Kyle. Okay, let's see here. Yeah, Kyle's a mod. Yep, you got it. Kyle's a mod, has the power. Kyle has the power. All right, let's keep going here. We got 8 minutes, so we got time. We got some time. So this is pretty neat. We're understanding this. So compare is just preparing, right? It's gonna look at these two items and it's gonna check if it's less than. Go to end if. Continue. See, the thing is that I think it's weird. This is the end if right here. Oh, got it. Okay. Now we're reading it right. Okay. So if it is not needed to be capitalized, then we skip and go down to continue, which should copy the character into the address that the target output, right? The target output register. Otherwise, we are going to increment it, or we're going to, in this case, we're going to subtract. So this will convert the lowercase. The character, the single character, is going to convert the lowercase character into an uppercase character. Just this one line right here. So this is neat. I'm not familiar with this syntax. Let's see if we can walk through the syntax really quick so we understand it better. Okay. Assembly. Let's walk through this real quick. Walk through this. Does the value change? Yes, W5 will change. So W5, register 5, will change. And I do believe it's going to convert it. So if it's lowercase a, it's going to convert it down to uppercase a. So it's going to subtract it down. Because for whatever reason, I don't know why they decided this, but capital letters are lower on the ASCII table than lowercase tables, which is confusing. Why did they do that? And why couldn't they put all the letters together? I think that would have been nice if they did that. Why? There's definitely a good reason. There's always a good reason. You jump back into the history and you look at why they made those decisions. You're like, okay, I get it now. I get it. I understand. Because they're of capital importance. Yep, capital importance. Yeah, you're right. That's another good way to look at that. I didn't even think of that, Kyle. Essentially, they're closer to number one, right? They're earlier on, so they are capital letters. They are capital important. That could be it. Hey, Simone, good to see you. Welcome on in. We've got about 5 minutes left, then we got to jump to a meeting. Let's see here. So this is where the actual, isn't this neat? This one line here, this one line, just this single one line right here is what performs the capitalization algorithm. Probably not. I don't know. You might be right. I think you might be right, Kyle. Actually, you've provided the best argument for why the table here, the ASCII table, has the capitalized letters first, because they're closer to one. They come first, right? And the lowercase comes second. It's just a different way to look at it. It's just a different way to look at it. Okay. So now strb, which is a store register, store character to the output string, right? So we take that. The output string is x1, and then we point. I do believe there is a pointer. This extra part here will increment a pointer of some sort. So W5 will then get put into X1, incremented. All right. Stop on hitting a null character. Stop on hitting a null character. Okay. I'm noticing how important simple code is to you, and I'm trying to adopt more simplified solutions when I code now. Thank you. Hey, yeah, it's so important. It's critical because it is essentially debt that you own at that point. So Kyle, you're doing amazing work. You're creating technology. You're creating new apps, and all the code that you write and that you generate, that now needs to be maintained. That is your debt. And then you lease that debt to others so they can leverage the value that you've provided in your code. The less code you have, the lower debt that you own, and essentially you've improved your margins in a way. You've improved your margins. Meme coin, how's it going? Why are you using assembly? I know, right? Why? Because we're learning assembly. We're not actually using it. We're learning it. You wouldn't today very much often use assembly for anything unless you're a low-level engineer looking to optimize. And it is useful to learn, which is what we're doing right now. We're learning, we're seeing how it works. We understand it. It's actually a lot of fun. It's really neat once you get it. It's kind of scary. Don't get me wrong. It's pretty scary. It is a scary language. Yes, I heard about debt, and a lot was going over my head for sure. And now you're in the whole world, Kyle. You're in the world. I love embedding with Rust. That's good advice. Nice. Rust is my favorite language. Rust is my favorite language. It just solves many problems that you run into in production. It's very fast. It's efficient. The compiler helps you prevent errors going to production. The pain is still there, right? It just makes all the pain up front rather than after you've gone into production, which is phenomenal. It is a great way that the programming language does that. All right, you guys, we got 2 minutes left and we got to go. We got 2 minutes left. It was a lot of fun to hang out here. So we'll keep going. Oh wait, so this is immediately return. Wait, where does this return? Why does that return immediately? Wait. Oh, no, it doesn't. Okay. So it compares to see if we got a null character. Otherwise, it's going to go back up to loop. And it's going to start over again. And it's going to continue on this. This part of code, I feel like I've gotten my full grasp of. I get it. It makes a lot of sense. I enjoy it. I understand now. I get every single line of code that you see here on screen. I understand each piece, not entirely. I understand what it's doing. For example, this line here where it's loading the register into the character, I understand how that, I get it. I just don't fully understand to know to leverage it yet. These items though, that's straightforward. This is basic if-else statements here. This is easy. This syntax right here that you're looking at, where A minus A, I'm not familiar with that. I don't even, before we go, because we've got 1 minute left, let's dive deeper. I want to see if we can get an AI to understand what is this. Let's understand this specific line right here. We're looking at this line right here. So sub is the subtract operator. Sounds good. W5 is the register. We know that. That's easy. What about this percent, this pound percent A minus A? A constant immediate value representing the difference between the ASCII. Oh, that's neat. I get this now. Okay, so this is like some sort of macro. This is going to take A ASCII value and subtract capital A ASCII value. And then it's going to apply that to the register, therefore making it a capitalized letter. We did it! All right, so we'll be back tomorrow with more. We'll continue this. We'll continue to see if we can get more on this capitalization going. And then that will wrap up our assembly. All right, everyone, thank you for joining. We'll be back tomorrow. Had a lot of fun. I know it was short today. Thursdays are usually short. So we'll be back tomorrow, and we'll continue this. Some could master assembly, write next generation operating system from scratch. Right? It's still useful. It still is. It could happen. It could happen. All right, everyone, got to go. Thank you for spending time with me.